restriction mapping. Okay, so what they are tell us that a linear fragment of the DNA is clipped with individual restriction endonuclease HIN3 and SMA1, and then with a combination of the two enzymes. The fragment obtained are HIN3 SMA1 2.5 kb, 5 kb, 2 kb, 5.5 kb. Okay, and then as I have discussed with you in my basic principle discussion video that without any kind of double digestion you cannot find out the restriction map, right? So after double digestion they give three fragment 2.5, 3 and 2, and they want to they want us to construct the restriction map. Okay, so let's start. So first of all, how it can be done, let's discuss it first. Okay, so let's focus on the first restriction endonuclease. Okay, that is HIN3. So suppose you have to remember that at all the time the total length of fragment will be the same. 2.5 plus 5 in case of HIN3 gives you 7.5, right? Again in case of SMA1, 2 and 5.5 give you 7.5. Again HIN3 and SMA1 together 2.5, 3 that means 5.5 and 2 that means 7.5. Okay, that means here the total length is 7.5 kb. HIN3 divides this total length into two separate fragments, that is one is 2.5 and 5 kb, that I have drawn here. Okay, very well. Among them, now let's focus on the double digestion product. So what double digestion product wants to tell us that 2.5, 3 and 2, that three kind of fragment is generated. Okay, simple. Now if you focus that 2.5 is exactly the fragment generated by HIN3, then what we can conclude that this 2.5 is exactly this 2.5 that is generated by HIN3. That means the restriction side in case of SMA1 will be on the 5 kb fragment, right? And that is what the rest of the fragment want to tell us, that 3 2 is equal to 5. Okay, so if you focus that SMA1 has generated a fragment 2 kb, right? So what we can conclude, that SMA1 simply separates this 5 kb fragment into two fragments. One is of size 2 kb, another is of size 3 kb. So that is how the entire mapping is generated. So what they have done, you have to first focus on the HIN3 2.5 5 kb fragment generated. Okay, so 2.5 and 5 kb generated fragment. Now we will focus on the double digestion product. So there is one 2.5, very well. So this 2.5 is coming from HIN3, we have confirmed it, and this 5 kb is again digested by SMA1. Is it or is it not? Isn't it? So and generated two fragments 3 and 2 as it depicts. Okay, so if you multiply this 3 along with 2.5, what will you have? 5.5, that is the fragment generated by SMA1, and the rest is 2. So our exact calculation is accurate, right? So now you need to find out the orientation. What kind of orientation? You can write 3 2 or 2 3, the fact is same, right? So what you have to write, you need to find out. Now let's focus that if you multiply 3 with if you add 3 with 2.5, you will have 5.5 and 2 remaining. So in that case your perfect combination will be 3 and 2, not 2 and 3. Okay, but what will be if you use 2 3? then just multiply it 2.5 plus 2, that means 4.5. Is there any 4.5 in SMA 1? No, that means that combination will be wrong in that case, and there is no 3 also, so we have to rely on the first combination that we have chosen. So our first restriction endonuclease cut site is Henry, then this Henry will be the 1 Henry, that one, okay, and then SMA 1 and Henry 1. So that is how the restriction map is generated. Here the restriction map is linear because they have told us to that our DNA is linear fragment. If it will be a plasmid, then you have to simply join this Henry with this Henry. That's all. So that is the idea of restriction mapping problems. You have to first focus on the restriction endonuclease which has larger cut site. You can simply find out it, although here both have the same number of restriction cut site in the total DNA fragment, but if suppose Henry generates 3 fragment and SMA 1 generates 2 fragment, then our first step will be to focus on the Henry. Then our second focus will be to focus on the double digestion product, and by looking on the double digestion product, we are going to derive out the fragments, the possible the fragments and the possible restriction site. Then we will simply analyze the possible combination and we will construct the linear fragment map, and in case of plasmid, the circular map. That is the idea. So I have again come back with another kind of problem from restriction mapping. Till then, stay tuned.